So I'm trying something which is quite experimental. I just call it test one underscore pipe for now, and this is with the diffusers. So if you are not aware what diffusers is, so quickly just to whatever is my understanding, uh, to run diffusion models, especially with the Hugging Face interface or from Stability AI, you can go to diffusers, and it's been very actively developed. And one of the lead developers is from India. Uh, he's a wonderful open source contributor. He's been doing this for quite a while. So that is how I actually came to know of it, and I wanted to experiment with it. And this is what the code looks like. I've taken it from their official notebook. I just put it into a Py file. I don't like notebooks much. Why I don't like notebooks? I could write many essays on that, but that is not what this is about. So okay, so few very minor tweaks to their code. With some minor tweaks to their code, this is how it runs, and when it runs, it prints out a couple of things. It might print out this also, but I just googled that. We don't necessarily need to care about this. This is something which is anyway. Forget that. So here it is. Setup of environment and everything's already done, and so firstly we'll just observe what happens, and I'll try and explain then what is happening. So it is loading the pipeline components. It is using my GPU because it's already kind of done that. And here you go. So you saw a certain image, and then you're seeing number of images come up. So these are images getting written to the temp directory, and most of them are somewhere about less than 200 KB, around 160, 166 KB, 178. You can see that printing out. PNG images. So the initial. Okay, so now if you focus on the noise of the image, you'll start seeing a cat. At this stage, you can make out that there is a cat, and again you can't. Again you can, and there it is. So the final. This is a generated image. This is not a. This is not a real cat image, so you get to see a lot of I don't know what you would call it. You would call it the model's hallucination, or maybe I don't know, maybe just random noise also there. Like on top of the cat's ears, you can see two extra ears hanging around, or like where its tail is supposed to be. I don't know. You can see some other, and this cat doesn't really you can't really relate the eyes and the ears with those legs that you see. I at least I can't. Maybe it's on a carpet. Maybe it's been eating something. I really don't know. So anyway, so yeah, this is the generated image, and this last image would get saved in your directory, and the first image also. So let's go to the directory and have a look, see as to what those images are. And firstly, let me show you what happened earlier. Earlier, I ran it for 50 iterations, and 50 iterations is what is scheduled. So 50 iterations is what is scheduled in their initial code. So if you look at their code, this is their code, and they have 50 iterations over there for this pipeline to run through. 50, yeah. So scheduler time steps, right? So that's what it is, and then it becomes a tensor. So the same thing, I have ran it as 50 earlier, and then I have ran it as 150 now. So I've gone and changed it to 150, presuming that there will be a better generation, is what I'm presuming. I've not necessarily made sure of that. And this is the first image. This was the first image. It was this. I don't know what it was. It doesn't even look like a cat. And the end result for that one was this. Yeah. Again, you can see multiple cats over here. So I'm not really sure if this is how it is supposed to be. And now this was the initial, and this is the end result after. And those images which were being denoised, or rather we were introducing noise, uh, those haven't been saved, or if they have been saved, they've been saved in the temp directory. I'm not going to go to the temp directory and have a look at them right now. So this is how this is running, and all of this is from diffusers, uh, pipeline, UNet2 model, and scheduler. So this is just a initial experiment to understand how this code is running. Let's come back to this in some time.